So power is just work divided by time. This is a rate. Okay, it's a rate of work. Rate of work. So the more powerful, the less time. Right? That's usually what people in industry are looking for. They're looking for machines that can do a lot of work in a small amount of time. So less time, same work, more power. Okay? And we have work in joules divided by time in seconds. So we have joules per second. Joules per second will be known as the watt. Okay, joules per second. And you will find that this is very, very straightforward. Anything in there worth noting? Okay. Determine the power of a motor that does 226 kilojoules. Okay, what's the standard unit? Joules. Look at your data sheet. If you don't have your data sheet, flip to the back. Go to Appendix C at the very back. It's right on the back cover. Go to Appendix C. Everybody go to Appendix C. And I know most of you probably know what kilo is. Just go to Appendix C. What does it say for next to K? Kilo. That's mega, 10 to the 6. What's kilo? 10 to the power 3. So in your calculator, you can just go 226, that capital E, and then 3, and you will get an instant conversion. You don't have to think about it at all. Okay? So I want you guys to get into the habit of that. If it said megajoules, what would you do? 10 to the 6. Okay? And gigajoules? 10 to the 9. And that's a lot. So okay, so anyways, you have 226,000 joules in 30 seconds. So you get joules per second, which they're going to call the watt. I got like 7533 watt. Okay, and they're giving you a SIG-DIG 7.5 kilowatt. Okay, the next page, I'll let you guys try 2 on your own. Let's take a look at question 3. Back one off? Yeah. All right. So it says a 65 kilogram athlete, so lighter than me, right? Runs at a constant velocity. What does that mean? Not accelerating, and forces are balanced. So force is balanced. Up a 25-degree incline. So this person's probably training. Normally you run on a flat ground. While producing 2.5 kilowatts, so 2,500 watts. Okay, so 2,500 watts of power. Determine the time required for the athlete to run 20 meters up the incline. Formula, power equals work over time. What are we searching for? Determine the time. How to solve this very basic fraction equals fraction. Cross multiply, we have T equals W over P. Okay, so the work divided by the power. So the power was given 2,500 watts. Now the work. What is the work? What is the work? What is the work? What is the, well, what's a formula for work? Force times distance. Okay, do we know the distance? (20 meters, right? Okay, so force times 20 over 2,500. So what's stopping us from getting this answer? The force. Okay, think back to the dynamics unit, the studying the inclined plane. Draw the inclined plane. 25 degrees here. Help your teacher. What do we know? You have some person running. Whee! What is happening? Gravity, sure. Which component of gravity? Okay, well, we know gravity acting straight down. Gravity acting straight down. Okay. Which component of gravity? You're on a ramp, right? So you don't have to go straight up. You're not going against gravity completely. So which component? Parallel or perpendicular? Which force are you overcoming going up that hill? Zach, which one? Parallel or perpendicular? Thank you. You have to overcome parallel, or at least meet it. Okay? So, F parallel is the force opposing your motion, and you're running up, so you're applying a force up the ramp. And what do you know about those two things if it's balanced? The two vectors are the same magnitude, opposite direction. So F applied equals F parallel equals, what's F parallel? FG sine 25, right? Did they give us FG? What was it? Oh, they just gave us the mass. So 65, 9.81 sine 25. Help your teacher. $269 with some decimal. Okay, put it here. Times by 20, divide by 2500. You got the answer? 2.16, it matches? Okay, so we're good. And then it says, consider the world-class sprinters can run 100 meters on level ground in 10 seconds. So you just think back to, what's his name there? Usain Bolt? Usain? Yeah, he's awesome, right? He's amazing. So what can he do? The 100 meters in like 9.6 seconds? Like fast, right? So what are we saying that this person can do? They can do 20 meters in 2 seconds. So maybe just use some proportion. There'll probably be some error here because of speeding up. Times that by 5. Is this a reasonable answer? Is it? You can go up a 25-degree incline at the same time as a world-class sprinter? I don't think that's reasonable. Anyways, the 3B is not too important. You can think about 3B, but 3A is where it gets important, okay? And number 4, aside from some time conversions, it's very simple, and same with number 5. So I'll let you work on 2, 4, and 5 for 10 minutes, then I'll give you the power quiz. Okay, so open up your notes, and I'm just going to give you a small glimpse into some Science 10 review, basically. Okay, so open up your notes. Okay. And I'm just going to give you a little bit of notes, potential energy and kinetic energy, and I'll give you more formalized notes on Thursday in its connection to work. But for now, it's just a Science 10 review. So the first thing that you should already be aware of, having passed Science 10, is potential energy. Okay, and the potential energy, does anybody want to give this a shot? What is potential energy? If you're trying to explain it to an alien. What is it? Good, a force, not a force, but an energy an object would have, stored, you say stored? Good, I like that word. Stored energy, based on what? Height, if you're talking about gravity, for sure. So what is height? Displacement or a position. So potential energy is an energy that's based entirely on position. Okay? And that's the most important part. So let's put that down. The stored energy of position possessed by an object. So just imagine in your heads your best friend or your enemy, you know, standing above you, and they're about to drop a bowling ball on top of your head. Just from your everyday experience, you know that that's not good. So by holding the ball up in the air above somebody, you know it's not good. And you know if that hits you, it's not going to feel good. Okay, so it's energy based on position. What about, I'm trying to think of a good example. But what about like a slinky? Try to imagine a slinky in your head. Yeah, possible. Yeah, possible energy. I mean, possible implies that it might not happen if you let go. Yeah, friend. Yeah, possible, sure. We don't need to nitpick though. But you want to put possible, put possible. Think about a spring. What happens when you stretch a spring? Think about a slinky. What happens when you stretch the spring and then let it go? What does it do? Does it snap back? It snaps back, right? So what happens when you stretch the spring? What are you doing? You're giving it elastic potential. Good terminology. And what is that energy based on? If you only stretch it a little bit versus if you stretch it a lot before it breaks, which one's going to have more energy? It's based entirely on, position. And in that case, it would be displacement from equilibrium. So potential energy, I think that's good enough definition. Okay, let's give you a definition of kinetic energy. So kinetic, what do you guys think about when you hear the word kinetic? Moving. What's another word for moving? Motion. Okay, so the energy of motion. Okay, I recently was doing a Class 4 license upgrade for driving a vehicle. One of the things I read was about speeding. So, two cars, A and B, one's driving 40 kilometers, one's driving 30 kilometers an hour in a school zone, the other one's driving 70 kilometers an hour in a school zone. Little kids walking on the crosswalk. Just from your experience, which one's better? Yeah, because what happens, how hard is it to stop when you're going that fast? It's way harder, right? And then, man, I was reading some data on this pamphlet from the government of Alberta. It was like death rates for like if you're going 60 or 70 kilometers an hour versus like 30 or 40 kilometers an hour, it's like a 90% death rate to like 20% death rate. It's like a huge jump. So that's why they're really trying to, urge the citizens of Alberta not to speed in school zones, right? So energy of motion, and the formula for it is, everybody should know this from Science 10, EK is a half mv square. So the energy of a car, think about a car moving. Is the mass changing? No. So energy is proportional to the square of the velocity, okay? So you can say EK equals, or not equals, EK proportional to V square. So what happens if you double the velocity? What happens to the energy? If you double the velocity? Is the energy doubled or is it quadrupled? If you double the velocity, you quadruple the energy. If you have the velocity, you will what to the energy? If you have the velocity, what happens to the energy? Quarter. If you have the velocity, quarters the energy, right? So I think that goes back to like that speeding in the school zone. Like if you're going 50 versus if you're going 25, there's actually, instead of it being half the energy, it's a quarter of the energy. So I think that's what they're going after there. I haven't given you a potential energy formula because there's a bunch of different types of potential energy. So I'll just give you the EP grav. You could put EP grav, and you're already familiar with this from yesterday, MGH. Now just put a little note on this formula. Which H is it? Which H is it? There's lots of types of H's. Like think about a ramp. You're a person going up a ramp. Is it the distance on the ramp? Is it this X distance or is it this Y distance? Yeah, so you need to use vertical only. Vertical distance only. So just make a note of that. On that note, I'm going to stop talking. I'll give you more notes on mechanical energy later. You have 5.4 over today and tomorrow. I want you to be working on this maybe during East or, you know, while your social teacher's talking. And yeah, just putting up 5.4. Okay, here's the formulas. There is some stuff there on the relationships between work and kinetic. We're not going to go after that quite yet, but it's page 178. And I want you to try some of these questions over the next 2 days, because there's 13 of them over 2 days. That's not a lot. And it's mostly Science 10 review. Okay? So that's on you guys. I'm going to stop talking, finish up your quizzes. And hey, yesterday you guys are all out of your desks acting crazy with like 5 minutes to go. Don't let that happen again.